In this video, we'll be looking at the quotient rule, which is a rule to help you find the derivative of a function that is made up of two functions that are being divided. But before we get into that, we're going to do a little parameter warm-up. So determine the values of the parameters a, b, and c for the function, that parabola, if it contains the point 1, negative 5 and has a horizontal tangent at the point 2, negative 7. So first of all, right away, I am giving you two coordinates on this function, which means I can sub them in for x and y, and I'll have two equations in terms of three variables. So let's go ahead and do that first. I'm going to set y equal to negative 5 and all of the x's to 1. And this is going to clean up to negative 5 equals a plus b plus c. Then I'll do the same thing for the point 2, negative 7. All the x's are 2's. Clean this up. And when I clean it up, I'm actually going to place it right here. 4a, 2b plus c. The reason I'm going to do that, this is a great opportunity for me to do an elimination to eliminate the c. So I'm just going to subtract. Negative 5 minus negative 7 is 2. 1 minus 4, negative 3a. 1 minus 2, negative b. Okay, so these were my original equations, but at least now I've eliminated a variable and I have one just in terms of a and b. Now, we were given information about this horizontal tangent. A horizontal tangent line has a slope of 0, which means when x equals 2, the derivative is equal to 0. So let's find the derivative of this function. And when we find the derivative, we're going to treat a, b, c's as parameters. They're supposed to be numbers. They're not variables. So I'm going to bring the 2 down. It would get multiplied by a, and then x, and then plus b. Now let's replace the derivative with 0 and the x with 2. And let's clean this up. And now look at what we have. We have two equations with two variables a and b. So I'm actually going to take this one and bring it over here and do one more elimination. Now obviously substitution is perfect. I'm going to add my line so that the b's cancel out. And I have 2 equals negative 3 plus 4 is a, and the b's cancel. And there we go. I have my first parameter. Now I'm going to take this and I'm going to sub it into whichever equation I want. I'm going to go back in here. That's 8. 8 moves over. B is negative 8. And if I want C, I'm going to go back into one of my original equations. So I'm going to go back into this top one. And I'm going to write negative 5 equals A was 2. B was negative 8 plus C. 2 minus 8 is negative 6. It moves over. It's positive 6. So negative 5 plus 6 is 1. And there we have it. So our function is 2x squared minus 8x plus 1. And it will have those 2 points on it, and we could do a quick little left side, right side check, and its derivative when x is 2 should be 0. And we could check that as well. All right, let's get into the quotient rule now. So in the past, we have dealt with these types of quotient functions by taking the denominator and giving it a negative 1 exponent. And that's how we're going to start this off. We're going to do a little proof by making it a product and then using our product rule. But then we're going to clean it up and come up with the quotient rule. So I'm going to write this as p of x equals f of x times g of x to the power of negative 1. And now I'm going to do the derivative. So take the derivative of the first function, copy paste the second. Plus, I'm going to take the derivative of the second function, so the negative 1 is going to come down, so I'm just going to change that plus to minus. then it'll be g of x now is to the power of negative 2. And then with that power of a function rule, then we would take the derivative of whatever's going on inside, and then I'll copy paste the original first function. So there's one derivative, copy paste the second function. There's the second derivative, copy paste the first function. And now I'm going to clean this up. F prime and g of x goes back to the denominator. Subtract g prime and f of x all over that second function squared. And just to unite, I'm going to multiply top and bottom of that first fraction by g of x. And here is the derivative. Take the derivative of your first function, copy paste the denominator, minus take the derivative of the denominator, multiply by the original numerator, all over your denominator squared. So if you look at the numerator piece, it looks exactly like product rule, except we have subtraction, and then the denominator is the original one squared. Okay. Now, if you ever forget this rule, product rule is always there, comes in handy, just like we did previous days, but this is a little bit more efficient in terms of it creates that united fraction right away. So let's go ahead and do the first one. Determine the derivative of f at x. Okay, so we're going to take the derivative of the numerator, which is 3. Copy paste the denominator, minus, and if you ever forget the minus, it's because when we bring that negative exponent down, it turns addition into subtraction. Now I'm going to take the derivative of the denominator, which is just 2x, so I'm not going to add brackets around it, and then copy paste the numerator all over denominator squared, original one. Just going to clean up that numerator, distribute the 3 in, distribute the 2x in, careful with my signs. Going to collect my like terms in the numerator. And here is our derivative. Now, rational functions would usually have restrictions. This one isn't, because there's no way for my denominator to become 0. X squared, anything to the power of 2 is going to be positive. So even if I get positive 0, 0 plus 5 is still a positive number. Plus the bracket to the power of 2 will always make whatever's inside positive. So there's no way here. So done. Okay, next one. We're going to determine each derivative, and we're going to clean up the function and state the restrictions. Okay. So let's take the derivative of the numerator, which is 2, copy paste the bottom, minus derivative of the bottom is 2x plus 1, copy paste the top, all over original denominator squared. Now, if you wanted to, we could always factor out an x from the denominator. Maybe it'll cancel something out from the numerator later on. I'll just do that right now. Notice I am putting a double set of brackets here because that exponent of 2 also applies to the x, which I can show that as well in my next step. But for the numerator, let's expand. Okay, actually, I just want to save a little bit of space here. I'm going to do the distributive property up here. So 4x squared plus 2x plus 2x, and then plus 1, and then I'll distribute that negative in. I just don't want to write the fraction a million times. All right, let's clean up the numerator. Just collecting some like terms here, and the denominator, x squared and x plus 1 squared. Nothing to cancel out here. I could try to factor the numerator, but it won't work. So x can't be 0 and x can't be negative 1. Otherwise, we'll get 0 in the denominator. So there we have it. There's a quotient rule. There's some cleaning up and restrictions. Now the next one's going to be a little bit more interesting because I have this radical in the denominator. So it really is just x to the power of a half. So let's go ahead and see going to look like. So derivative of the top is 2x minus 4. It will get multiplied by root x minus the derivative of the denominator is 1/2 x to the power of negative 1/2. It'll get multiplied by x squared minus 4x. And that'll all be root x to the power of 2. Now, this one's going to be a little bit more for the cleaning up. So, I'm going to leave this like this for now, because I'm going to have a fraction within a fraction. So x to the power of negative 1/2 will go down into the denominator, and the numerator will be x squared minus 4x. And that's all going to be over x. And now when I see this, I kind of want to unite my numerator. It's technically over 1. So I'm going to multiply top and bottom by 2 root x. And here's why I didn't distribute that root x in, because those will become a nice x, which is nice. So we're going to have the 2 is going to multiply. So this portion here just becomes 2x. So I'm going to distribute it in. So 4x squared minus 8x minus, this numerator already had what the denominator needed, so I'm just going to distribute the negative in, minus x squared plus 4x, and it's all over 2 root x. And just instead of writing all over x, I'm just going to think in my head, I'm going to write divided by x, but dividing by x is the same as multiplying by the reciprocal. Okay, so I'm going to clean this up. My numerator, I have 3x squared, I have negative 4x, all over 2x root x. And if I did want to take it a step further, I could multiply top and bottom by root x. It will make the numerator look uglier, so I think I would just keep it like this in case I had to do anything. Okay. Actually, I could even factor out an x from here. Just gonna put it out front. I could have this, and then I have a pair of x's that cancel out. Okay, and in terms of our restriction, x can't be 0 because of the denominator, but x has to be 0 or positive because of the radical. So together, that just means x is greater than 0. So a bit more of a tedious one for cleaning up. Now, in terms of cleaning up, I did it because the question asked me, but also I would clean up to this level if I had to set my derivative equal to a certain number. If I had to take this further and solve, I would definitely clean up before I do anything. If I just had to find the slope at a specific point, the slope of the tangent at a specific point, I don't have to clean up. I could go from whichever step I prefer. All right, let's determine the second derivative of this function, and then we'll have a few little typical follow-up questions. So when we have to do a second derivative, we're going to do the first one, and we're going to clean up the first derivative as much as we can before we continue with it. So, g prime. Derivative of the numerator is 4x. Copy paste the denominator, subtract. The derivative of x plus 1 is just 1, and it'll get multiplied by the original top all over x plus 1 squared. Okay, I'm going to clean up my numerator. 4x squared plus 4x, subtract 2x squared, subtract 1. Collect my like terms. Unfortunately, nothing canceled out. Like there was no factoring GCF in the 2 units that I could do. So this is as good as it's going to get. All right, let's get into that second derivative. So derivative of the numerator, here it is. Copy paste the denominator minus time to take the derivative of the denominator, and we do have a power of a function rule, so we have to be careful here. Bring the 2 down, copy paste the inside, subtract 1 from the exponent, so just to the power of 1, times the derivative of the inside is just 1, so it doesn't make a difference here, but it's important you remember that you have to take that derivative because it's not always just going to be 1. Then copy paste the original numerator, and now x plus 1 squared is going to go to the power of 2, so it'll be to the power of 4 when I clean this up. And now when I look on top, I do see that both of the units have an x plus 1 in common, so I'm just going to factor that out, just one of them, and that'll leave 4x plus 4 with an x plus 1. It'll leave negative 2 with that trinomial, so I'll have a little bit of distribution to do in collecting. And on the bottom I have x plus 1 to the power of 4. And here's why it was good that I factored out an x plus 1, because now one of them will cancel out. So if I had to do more math with this just helps clean it up. Okay, let's deal with that numerator. 4x squared plus 4x plus 4x, so 8x plus 4 minus 4x squared minus 8x plus 2. And now, clean up that numerator. 4x squared is cancelled out. Ooh, the 8x is cancelled out as well. So just 6 over x plus 1 cubed. And my restriction, x can't be negative 1. Perfect. So this was really just an exercise, not just the quotient rule, but cleaning up our functions. All right, the next one is the very typical question. Determine the equation of the tangent to the graph y equals that rational function at x equals 0. So first step, let's find that derivative, and then that way we could get the slope of the tangent line at 0. So y prime, or I could write dy dx, derivative of the numerator, copy paste the denominator, minus derivative of the denominator, copy paste the numerator, all over x squared plus 1. Now, I could technically leave it like this. I am not going to be setting the derivative equal to anything, so I could just set x equal to 0 here and be on my way. So I think I'm going to do that. I'm just going to find my slope. 3, 0 squared plus 1 minus 2 times 0, 3 times 0, all over 0 squared plus 1. So I'm going to have 3 times 1 is 3, minus 0 is 3, and the denominator will be 1. So the slope of the tangent line is 3, so my equation will be y equals 3x plus b. I'll find the coordinate itself as well. When I set x equal to 0, the numerator will be 0, the denominator will be 1. So the coordinate is just 0, 0, which means that is the y-intercept. So the equation is just 3x. There we go. Typical question, but now with the quotient rule tweak. Okay, the next two are going to be an exercise in being very careful and not losing track of the different rules, because we have these rational functions, so quotient rule for sure is going to happen. But if you notice in the first question, we also have a product rule on top, and the next one we have a power of a function rule top and bottom. So just being very careful of when you're taking the derivative, when you're copy pasting something original, making sure you find a derivative fully is important, because these questions are going to be quite long. So I'm going to start off by taking the derivative of the numerator, and the numerator has a product rule. So the product rule says take the derivative of the first function, here it is, copy paste the second function, plus the derivative of the second function, which is 2, copy paste the first function. This here was the derivative of the numerator. Now I'm going back into my quotient rule. There's the derivative of the numerator, copy paste the denominator, minus, now I'm going to take the derivative of the denominator, 3x squared minus minus 1, and I will copy paste the numerator, untouched. So as you can see here, that numerator derivative took up a lot of space because it was a product rule. And now, denominator squared. And we'll keep it like that. I said keep it in unsimplified form. Here is just practicing our attention and keeping track of what we're doing. Okay, r prime. So I'm going to take the derivative of the numerator, and the numerator has that power of a function rule. So bring the 3 down. Copy paste the insides. Now it's to the power of 2. And I'm not done with this derivative. I have to take the derivative of the inside now. 15x to the 4 minus 3. Notice I didn't take that derivative in here. First you're taking the derivative of the outside function, then you take the derivative of the inside. Now I can copy paste the denominator. Minus, now it's time for the denominator derivative, so bring the 1/2 down because that's what the exponent is. Copy paste the inside. It's now to the power of -1/2, and then it'll be multiplied by the derivative of the inside. Then I have to remember, because this is getting long, I still have to multiply by the original numerator. And that'll be all over the denominator squared. And there we have it. Now I did just realize I didn't put restrictions for any of these. I could add those in. So this denominator would factor out an x. Okay. And I have a difference of squares there as well. I don't see any radicals, so my restrictions would be x cannot be 0, -1, or 1. For the next one, these ones would cancel out, so x can't be 5/2, or it'll make the denominator 0. But I also have a radical up here and down here, so that has to be greater than 0, so x has to be greater than 5/2. All right, final question. Determine the coordinates on the graph of f at x where the tangent line is horizontal. So that means we need to set our derivative equal to 0. We've done these questions before, but now we could do a quotient rule. So f prime of x is going to be derivative of the top, copy paste the denominator, minus the derivative of the denominator, so 1/2 x to the power of -1/2, copy paste the numerator, all over denominator squared. Because I do have to set this equal to 0, I am going to clean this up for solving purposes. So I'll have 2√x minus, when I bring the negative exponent down, I'll have 2x plus 8 on top over 2√x, and actually just going to erase this and factor out a 2. That way those two can cancel out. And then for the denominator, it's all over x because √x all squared. And then from here, I'm going to get a common denominator. So this is over 1, so I'll just multiply by √x, so that we have 2x subtract x subtract 4, because I'm distributing that negative in, all over √x. And like I've done before, instead of writing divided by x, I'm going to write times 1/x, so that we have x subtract 4 over x root x. And now I can set this equal to 0, and whenever we have rational functions, just because of the cross multiplication, we get 0 equals the numerator, so x must be 4. So at 4, the tangent line is horizontal, which if we think about when tangent lines are horizontal, this might be when a graph is changing direction, so it's a max or a min. If I want the actual coordinate, I'm just going to sub 4 into the function itself. So 2 times 4 is 8, 8 plus 8 is 16, and then the square root of 4 is 2. So here's my coordinate, where the tangent line is horizontal. And there's your quotient rule. Typical follow-up questions. Derivatives can be a lot more complicated if we combine a question that has product rule, quotient rule, and power of a function rule. So we do have to be very careful now when we take derivatives, but otherwise the follow-up questions, similar style, just more complicated derivative, and maybe the algebra and the cleaning up is a little bit more than usual.